In this question, a sample of diatomic oxygen, O2, has a volume of 50.6 litres at STP, that's standard temperature and pressure. Diatomic oxygen has a molar mass of 32.00 grams per mole. Our goal is to find the mass of the sample. So we're starting out with 50.6 litres. First, we're going to have to convert that into moles. Then we're going to have to convert from moles to mass. So the first thing we need is a conversion factor between moles and litres. So let's head to our equation sheet. Down here, we can see our STP, standard temperature and pressure, which is 273 Kelvin and 1 atm. 1 mole takes up a volume of 22.4 litres. That's for an ideal gas. So that's going to be our conversion factor. 1 mole equals 22.4 litres. So we can go ahead and fill in our conversion table here. We want to get rid of litres, so litres is going to go on the bottom so that divides and cancels out with the original litres. We're going to put moles on the top because we want to get to moles before we can get to grams. Then we need to put in our numbers so that the top and bottom of this fraction are equal. So 22.4 litres is equal to 1 mole. So that's going to be our first stage of our conversion. So we've successfully converted from litres into moles. Our next step is to go from moles into grams. The conversion factor for that is going to be the molar mass of our compound. So our molar mass is 32.00 grams per mole. So what that means is 1 mole of oxygen O2 is equal to 32.00 grams of O2. That's what 32.00 grams per mole means. So that's going to be our conversion factor that we're going to use now in our table. We're going to have moles on the bottom, so that will cancel out again. And we want to get into grams, so that's going to be on the top. And then the top and bottom of our fraction need to equal each other. So we've got 1 mole is equal to 32.00 grams. Okay, so our dimensional analysis table is now complete. We've started with litres, we've ended in grams. Now we can go ahead and multiply together everything on the top, multiply together everything on the bottom, and divide top by bottom. Any units that are the same on the top and the bottom are going to cancel. So the litres cancel and the moles cancel. And we're left with 50.6 multiplied by 1 multiplied by 32 grams divided by 22.4 multiplied by 1. So we're going to put that all into our calculator, and that gets 72.3 grams. So we can fill that into our answer box now. So same as the previous skill, we're using 1 mole of an ideal gas is equal to 22.4 litres. We also need to use the molar mass of our compound as our second conversion factor to get then from moles into grams. Remember, this only works at standard temperature and pressure, STP. If it's not at STP, you're going to need to use the ideal gas equation to figure out how many litres of gas is 1 mole. Let's do one more question of this type. This time, we have a sample of diatomic chlorine, Cl2, that has a mass of 116 grams at standard temperature and pressure. We're told diatomic chlorine has a molar mass of 70.90 grams per mole. Okay, so same as last time, the molar mass is going to be one of our conversion factors. So let's write that down. 70.90 grams of Cl2 is equal to 1 mole of Cl2. So that's going to be one of our conversion factors, along with the 1 mole equals 22.4 litres of gas at STP. Okay, so going to our dimensional analysis table, this time we're starting in grams. We're trying to get volume in litres. So our first step is going to be going from grams to moles, then we're going to be going from moles to litres. So we're going to want grams on the bottom and moles on the top, so that the grams cancel out and we're left with moles. Then the top and bottom of this fraction need to equal each other. We know that 1 mole of Cl2 equals 70.90 grams of Cl2. So that's our first conversion. Next, we need to get from moles into litres. So we're going to have moles on the bottom, so the moles will cancel out, litres on the top, and we know that at STP, 1 mole is equal to 22.4 litres. So those are our steps. We've successfully gotten from grams to litres. Now we're going to multiply everything that's on the top, multiply everything that's on the bottom, and divide top by bottom. Any units that are the same on the top and the bottom are going to cancel. So grams cancel, moles cancel, and we're just left with litres. So that gives us 116 multiplied by 1, multiplied by 22.4 litres, divided by 70.9 multiplied by 1. So we can put that in our calculator. That gets us 36.7 litres. So we can fill that in here now. So again, the main thing to remember in these questions is that we're using our STP conversion, 1 mole of gas equals 22.4 litres, and we're using our molar mass as our conversion between grams and moles.